Don't. Yes, Jonathan. Yes, not math related. Sure. Okay. Okay. All right. John is talking about his plan someday to launder money. He doesn't want to pay taxes. You're going to accumulate enough wealth. Okay. If I were to move out of the country, I would definitely move towards somewhere where, Australia or New Zealand would be a prime place to go. Um, I would consider Switzerland. The problem with Switzerland is it's so expensive to live there. So I'd probably go in Australia. Very much allies the United States. I think he'd fit in well. Be a good fit. So you're afraid of the IRS. Got it. I'm not afraid of the IRS. I've got nothing to hide. I pay my taxes like a normal person. Yes, yes. All right, here we go. We will think about John's plan. We'll put it to the test. It'll be fun to follow up with him. We know we won't see him at the reunion because he will be trying to evade tax fraud. So we'll see how that works. Go to Fiji. If I have this kind of triangle, don't write that down. But if I have that kind of a triangle, can I solve that using the law of sines? How? Sine of what? Sine of 130 over something. Is it sine of something over 13? You can't solve this, can you? No, because the law of sine says this. You need an angle on its opposite side, don't you? I don't have an angle on its opposite side. So what do we do? Or what do we do if we have this? Suppose we have like 10 and 13 and 19. Could you use the law of sines there? Couldn't use the law of sines there either. You don't have an angle. So you learned in geometry that if you have side, angle, side, or side, 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 that's a good thing. That's a congruence theorem. But yet, we see in this example that we have trouble. So we need a new theorem, a new formula. A, B, C. Side A, side B, side C. I'm going to drop down a height. I create two triangles, and I'd like to say something intelligent about all three sides. I want a formula that involves A, B, and C. Something like the Pythagorean Theorem. A squared plus B squared is C squared. That would be really nice, but that only works if we have what kind of triangle? A right triangle. So I'm going to call this side X here for that smaller triangle. And if this is X, then what is this length right here? C minus X. Very good. I now have two triangles, and I'm going to do something really cool. I'm going to write the Pythagorean theorem for each triangle. The first one is going to be x squared plus h squared is equal to what? B squared. And I have another one, c minus x quantity squared plus what? H squared is equal to a squared. Hey, what do those two formulas have in common? They each have an h squared. In fact, h squared is equal to b squared minus x squared. If I know h squared is equal to b squared minus x squared, what can I do with that piece? Substitute it, and then disappears h altogether, doesn't it? So I really have got two goals with this formula. Get rid of h and get rid of x. So far, I've accomplished the first. C minus x quantity squared plus b squared minus x squared is equal to a squared. Everybody agree that the h's are gone? Hey, I got an idea. How about we multiply out this c minus x? And when we do, maybe the x's will be gone. I get c squared. Then what? Minus 2cx. Then what? Plus x squared plus b squared minus x squared equals a squared. Why? Wasn't that nice? In fact, you've got a really, really nice formula left over. I know it looks messy. We've got a lot of stuff up there, but just look at what you have. You've got an a squared. You've got a b squared. You've got a c squared. I mean, that really looks like the Pythagorean theorem for the most part, doesn't it? But then we got this adjustment. It's this little adjustment here, this minus 2cx, whatever the heck that means. You see what's happening geometrically is this. The Pythagorean theorem works for what kind of triangles? Right triangles. But if we make that right angle smaller, then the hypotenuse becomes smaller. And so you'll subtract some stuff off. But if that right angle becomes bigger, then the hypotenuse is going to become bigger. And so we would actually add something on. And so this is your little adjustment piece. If only I could get rid of x. If only I could find where x is up here and think of some type of trig function that involves the stuff around x. Tangent of a would be h over x. I don't want h. I just did a lot of work to get rid of it. Cosine. Cosine of angle A is equal to what? Close. X over B. I could now get rid of x, couldn't I? I just simply multiply both sides by b. B times the cosine of A is equal to x. This guy right here, I can dump in right there. And so I get a squared is b squared plus c squared minus 2bc cosine of angle A. And there it is in all of its beauty. The law of cosines. Complicated, yes. So go home tonight and try to prove it on your own. And if you can't, then watch the video and then try to prove it on your own. And do that until you can finally produce the formula on your own. It's a fun thing. Yeah. No, you don't have to do that. In fact, somebody said first out, why don't you just give us the formula? We're going to write down the law of cosines, but you're going to make sense of it other than just looking at the letters, because it's something that's really cool. It actually makes sense. And we're going to start with this piece. The law of cosine says in its most usual form, c squared is equal to a squared plus b squared. That's awesome, right? You know that. But we have a correction to it. We minus, and here's all it is. Look at folks. A squared plus b squared is c squared, right? So here's what you do. It's a squared plus b squared minus 2ab. So you just double those two multiplied together times the cosine of the included angle. That's that. So then we could switch it. We could say, well, suppose we want b squared. Well, how do you think the letters change? A squared plus c squared minus 2ac cosine of b. Excellent. Notice that whatever side you're solving for, the angle is what you need, right? You see, the law of cosines allows you, if you're looking for side C, you need angle C. Okay, it gives you the opposite side. And finally, a squared is b squared plus c squared minus 2bc cosine of a. You got it. Let's start the first example. We're going to do 2. You're going to then get to your homework. You have 6 problems. It's as short as I can make it and still have you be able to learn what you're supposed to do. Here we go. A, B, C. 26 degrees. B is 12. C is 15. So, Dr. Henschel, what kind of triangle is this in terms of sides and angles? Side, angle, side. Everybody agreed? The problem is I don't have an angle on its opposite side. If I look at my decision tree, this is an awesome piece. It tells me, hey, side, angle, side, there's one solution. Use the law of cosines. And that's where we start. Law of cosine says we are going to look at an angle, and then we're going to try to find its opposite side. So which side are we solving for in this example? You're solving for A. So A squared is, and we simply do that squared plus 12 squared minus what? 2 times 15 times 12 times the cosine of 26. Yep. See, it's all that side angle side stuff that you're given there. Now, your calculators understand order of operation. So this is going to go awesome for us. All we got to do is just type it in. So many people today have not brought their calculators in other classes, and they leave them in their car, and so they end up using their Chromebook for a calculator. That's really inconvenient. But if that's you, I guess that's just you. So 15 squared plus 12 squared minus 2 times 15 times 12. I do cosine of 26. Boom. Your calculator gets the order of operation. You just type it in, make sure you're working in degrees, and you press enter. 45 units. Agreed? No. Square root. 6.74. I now have all of my sides. A is 6.74, B is 12, C is 15. Angle A is 26 degrees. That wasn't too bad, was it? You just type it in and let the calculator do the work for you. What do you think I do in order to find one of the other angles? And that's where we'll pick up when you get back from your lunch. Law of sines. Okay, here we go. Everybody with me how we came up with the first side? So the rest of it we can make easy except for this one part. This is where people get confused. Gotta follow through, okay? Lean in, figure this out. True or false? It's possible for B or C to be an obtuse angle. Possible. True or false? It's possible for B to be an obtuse angle. False. Why? It would have to be angle C, right? Yeah, because that's the bigger one. So let's think about our problem here now. Everybody like this whole like side angle side thing going on. Now that we have an angle on its opposite side, you can use the law of sines, correct? So let's think about that. And this is where it gets a little tricky. We got sine of 26 divided by 6.74 is equal to sine of, we have to figure out whether to use B or C. And this is the idea. Where is sine positive? Quadrant 1 and 2. So sine does not know the difference between an acute angle or an obtuse angle, does it? No, it doesn't. Cosine. Is cosine positive or negative in the first? It's positive or negative in the second? It's negative in the second. So that's what's really cool about cosine, is that if you take cosine, and if I turn my calculator on here, I go, cosine inverse of 0.5, I get 60. If I do cosine inverse of negative 0.5, I get 120. Cosine can find obtuse angles, whereas sine, you got no shot. You do sine inverse of 0.5, you get 30. You do sine inverse of negative 0.5, it gives you negative 30, whatever that means. It can't find an obtuse angle. It can't find it. So sine is great at finding acute angles, but not obtuse. So If sine can't find an obtuse angle, which angle should I solve for? B. Here is what Hannah will rely on. Hannah gets to her test. She sees that this was a side angle side triangle, right? She uses the law of cosines. When you use the law of sines to find the missing angles, start with the angle opposite the shorter of the two sides. So I go to this guy right here, and I check it out, and I see that, do I want to solve for angle B, who's opposite side is 12, or angle C, who's opposite side is 15? I go to the shorter one in this scenario. So I cross multiply, and we go 12 sine of 26 divided by 6.74. Can sine be equal to 0.78? Sine inverse that answer. I got 51.3. Now I just subtract from 180. 180 minus the answer and minus 26, and I get 102.70. So did I end up with an obtuse angle? I did, but here's the key, folks. If you would have put C there instead of B, here's what you would have found. If I take the sine of that guy, I get that. So you know how we came up with the 0.78 we inversed? Well, if you solve for C, you would have come up with that. And when you inverse that, you don't get the 102. Sine can't find the 102. It finds 77. And that's not correct. So that's why you have to be careful. Question. 180 minus that does give us that, but how do you know for sure that it is obtuse? You don't. You don't. You're saying to yourself, well, is it 102 or is it 77.3? How do we know? Here's how we know. We find the 55, and when we subtract these two from 180, we get that, not that. That's why we know the 102 is correct. Otherwise, we got no way of knowing. All right, cross off example 2. Let's look at example 1. We're not going to do area today. I told you we're going to skip that. We're going to do example 1. I draw my triangle, A, B, C, and I label my sides, 10, 8, 12. So I've got A is 10, B is 8, C is 12. A for the day. What kind of triangle do I have? Side, side, side. Everybody good with that? So this is unique because we don't have any angles. Our decision tree says if you're given side, 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 use the law of cosines, start with, or to find the missing angle. Now, here's the cool thing. We're going to wrap up our discussion about this whole acute and obtuse thing. Okay? True or false? There could be an obtuse angle. True. Which angle would it be? See, everybody agree that angle A is definitely acute, and so is angle B. So, can cosine tell the difference between acute and obtuse? Yeah, yeah. If we get like a negative 0.5, then it's obtuse. If we get a positive 0.5, then it's acute. Cosine knows the difference. So we're going to use the law of cosines, and in this situation, we start by solving for the largest angle. Because after that, we use the law of sines, and the law of sines has no problem finding acute angles. So let's find the largest angle. What's the largest angle? C. So therefore, we set up 12 squared is equal to what? 8 squared plus 10 squared minus 2 times 8 times 10 times cosine of C. Now, here we can't just type it all in because our variable's sitting over there, right? And sometimes people make a mistake. They actually like combine all this together. You can't combine all that together, folks. Order of operations says we add, we multiply. And since you don't know what cosine of C is, you can't take these and add them together. So we're going to move that guy over and that guy over here, okay? So we're going to subtract those on over. So I'm going to turn on my calculator, and I'm going to take 12 squared I'm going to subtract 8 squared. I'm going to subtract 10 squared. So that means on the left-hand side, I now have negative 20 equals. Now we'll multiply. Notice we have a negative here. Negative 2 times 8 times 10. Negative 160 times the cosine of angle C. Divide by negative 160. And those are the common mistakes that people are making as we went through this. People are adding 160. We got to divide that guy off. You get 1/8 or 0.125 is equal to cosine of C. So is cosine positive or negative? Positive. So is it going to be acute or obtuse? Acute. So we don't have any obtuse angles at all. So we cosine inverse 0.125. We get 82.82. We know that that's the largest angle. And because it's the largest angle, the other two are going to be acute. I can set up the law of sines with no worries about any obtuse angles. I have the sine of 82.82 over what? 12 is equal to, do you want to do A or B, Jaden? B. Sine of B over 8. I solved that by multiplying both sides by what? 8. 8 sine of 82.82. I get that, and I divide by 12. Sine can be 0.66. I simply sine inverse that answer, and I get 41.41. So now 180 minus 82.82 minus 41.41, which mysteriously is exactly half of the other one. And I get 55.77. It is spooky. Hey, your time. 6 problems. Go. Folks, this is, like I used to give more. This is as short as I can make a question. No solving for area. I'll take you through that some other time. What up, dog? You did. Yep. Don't worry. It's only the hardest one of the unit.